Hello, fellow students. Today we are going to work transforming a grammar into a Greibach Normal Form. As you know, this form has some advantages when using, for instance, push-down automatons. So we are going to work on the practical side of these exercises. For that, I'm going to share my screen with you. And we are going to start with the problem that we have for today. So we have this grammar that is the one that we want to transform to Greibach Normal Form. And as you see, we have 4 different variables, S, A, B, and C. And then we have these production rules. Well, we already have a video in the channel where we review all the different steps that we need to follow from a theoretical perspective. And here we are going to see the practical approach. So the first step is to simplify the grammar, right? We should remove unit productions. These are the ones where one variable derives in only one variable. And as you can see, we don't have any of those cases here, right? In all the production rules, we derive in a terminal or in several variables or combination of variables and terminals. So we don't have any of these. Then we need to remove lambda or epsilon productions, depending on the naming convention that you are using. You could use lambda or epsilon. And as you can see, neither we have any of these productions in types of productions, right, in our grammar. Well, I won't stop too much on this point because I'm already planning to upload some exercises to the channel covering these points, right? So we will see more examples of these specific points in other videos that you can check in the channel. Then we need to remove useless symbols. This is not mandatory, but it will help to simplify the grammar and to make easier the following steps. And this includes dead symbols and inaccessible symbols. So for instance, to start with the dead ones, remember that we need to make the group of the alive symbols, right? So that means that we start with the variables that generate a terminal. For instance, here it's C and B, right? As you can see, they end up producing terminals. So these are alive. And then we incorporate to this group the variables that produce either one of these variables or a combination of these variables and terminals, right? So on each step, we need to add to the group of alive variables the ones that produce these ones or a combination of terminals and the ones that are already alive. So now we can incorporate S because S has a combination of B and C. And then, and also in A, we have a terminal. So at the end, as you can see, all of the variables in the grammar are alive because deriving from all of them, we can reach terminals. And then we need to, so we have not dead symbols. Then we need to find the inaccessible symbols. And for this, we do the opposite. We start by the initial symbol of the grammar, and we go forward, and we add to the group of the accessible, right? So this was the alive. Now for the group of the accessible, we start with S, which is also always accessible, the initial symbol. Then we add, in the next step, we add the variables that we have in the right-hand side of these productions from S, which are A, B, and C, because we can access them from S, so they are accessible. A, B, and C. And in the next step, we add all the variables and symbols and terminals that are accessible from this group, right? So we go to A, and here we can add also lowercase b, which is a terminal. From B, we can add C and B. We already had B, so we add C. And from uppercase C, we can add lowercase a, right? So again, all the symbols from the grammar are alive and accessible, right? So we don't have useless symbols here on the grammar. Okay, so that's all for the simplification. Then we go to the next step, which is to order variables. Here we can set any order that we want. We can place the initial symbol everywhere here, but just for, I don't know, consistency, I'm going to use the proper order of the grammar, right? Starting from the initial symbol, which I will say that is the lowest, and then the order is A, B, and C, right? Being C the highest variable in this order. Okay, once that this is done, according to the next step, we need to classify productions on the grammar. So we have three different types of productions. We have the first type, which is the productions that begin with a terminal. So we go to the grammar, and every time that we see a terminal, for instance here or here, right, starting the right hand of a production, we say that this is type 1. Then we go to the second type, and the second type is a variable producing another variable, which is higher in the order that we have set in the previous step. So some examples would be S producing something starting by A, B, or C, right? So we go from lower to higher. So here, in type 2, we go on this direction, right? So this would be type 2. If we go to the grammar, we can see that we have this type of productions here, where S produces something starting by B, as B is higher in the ranking. This is a production of type 2. And we also have S producing a C, which is also of type 2, right? We go on this direction from lower to higher. So this is also type 2. And finally, we have type 3. In type 3, a variable produces something that starts with another variable or the same, that is lower or equal in the order. So, for instance, here we go for type 3, we go on this direction, right? We go from higher to lower, right? And this would be type 3. So in this grammar, we have the remaining production rule, which is A produces something that starts by S, right? So we go on this order from right to left, and this is type 3. Right, so these are the first steps. Now we need to see how we transform every production of any of these types to the shape of Greibach normal form. And we will start by the productions of type 3. So let's see it in the next page. Okay, so in the fourth step, we need to remove type 3 productions. And we need to follow, we need to take all of these actions to remove type 3 productions. Okay, so let's review the theory. First, we need to choose the lower variable that we, according to the order that we set in the second step, that has type 3 productions, right? So we need to start looking by S, and then if it doesn't have any type 3 productions, we go to A, then we go to B, and then we go to C. When we find a variable with this type of productions, we need to replace the variable on the right side of the production by with its productions using the first lemma, the substitution lemma. But if there is a production where we produce the same variable, right? This should be like this. If we produce the same variable, we need to apply the second lemma, removing left recursion. And then if we remove left recursion, we need to introduce a new variable that will be the lowest, right, in the order of variables. So if we put a new variable, we will put it here, like the lowest. And then we need to repeat these steps with the lower variable until there are not type 3 productions. So if we finish with S, we go to the next one, and so on until there are not type 3 productions on the grammar. So let's see an example, right? If we start by the lowest variable, right? It's S, but in S we don't have type 3 productions. We only have type 2 productions. So we go to the next one, which is E, and in E we have a type 3 production, right? So what we need to do is to apply substitution here. We replace this S that we have here, we replace it with its production rules. So instead of having SB, we will have BCB and ACB, right? We just replaced that S with its production rules here. And this is the first step. Now we are still in the same variable. And as you can see, now we have a left recursion here, right? We have left recursion. So we have A, and this A produces something that starts by uppercase A. So we need to remove this left production, this left recursion, right? And to do so, we apply the second lemma, which is the substitution one. right? So we have a production rule of this type, right? When a variable is producing something that starts by itself, and we need to replace it by two different productions, introducing a new variable. So to do so, we need to identify what is alpha1 and alpha2. So in this case, alpha1 is the right hand of the production where we don't have left recursion, which is these two production rules, right? So this is alpha1. And then alpha2 is what is after the left recursion. So it will be this chain, right? This will be alpha2. So now if we use the template, first, we need to have the variable that we previously had, which in this case is also A. And then we have, on the one hand, alpha1. We just write alpha1 as it was before. All right, so we repeat alpha1. And then we have again alpha1, but now followed by the new variable. Right, so in this case, the new variable will be E. And we type here alpha1 followed by the new variable. All of this is alpha1. Okay, so now we go to the new variable. We go to the new variable, which is E in this case. And here we have alpha2. Right, so this was alpha1. And here in the new variable, we have alpha2, which is what's accompanying the left recursion here. Right, so we just write alpha2 and then we have alpha2 followed by the new variable. So we have alpha2 here again. And this is the way we apply this template, right? Remember that this production rule generates the same the same language, right? That these two production rules. So we lose left recursion, but for that we need to pay adding a new variable, right? Which in the template I called D, but here in the example it's E. Now, once that we introduce a new variable, we need to set a new order. Well, the order basically will be the same, but the new variable will be now the lowest, right, on this order. And as you can see, we don't have any more type 3 productions here on the grammar. So we can move forward to the next step. Okay, in the next step, we need to remove type 2 productions. So now we go on the other direction. We go from, we look from the higher variable to the lowest. And for that, we need to replace what is on the right hand of the production, right, with its production using the first lemma. I think that I have a copy-paste problem here, right? Because this should be like, and here you shouldn't find left recursion. So it should be something like this, right? Okay, now it should be fine. This step is simpler than the previous one. So we only need to find the type 2 productions, the productions that produce a higher variable on this order. And now we start to look from the higher variable to the lower variable, right? So we start looking by C. In C, we don't have any type 2 productions. We produce a terminal. So we go to the next one, which is B. On B, we produce 2 terminals. The next one in the order is A, and in A, we have 2 type 2 productions, right? So this is type 2, and this is type 2. These ones that are marked here, because from A we are deriving in B. So we replace B here by its production, by CB, right? So we write CB and then what was following B in the original production, which was uppercase C and lowercase b in this case, and uppercase C, lowercase b, uppercase E on this different case, right? So now we have removed type 2 productions from A, and we go to the next variable from higher to lower, which is S. Again, in S, we have 2 type 2 productions, right? We have B, S produces B, which is higher in the order, and S produces A, which is also higher in the order. So we need to replace B by its production, which is lowercase cb, and then uppercase C will follow this. And on the second rule, we need to do the same and replace A with its production. But in this case, the production rules from A are quite long, right? We have 4 different production rules. So we start by lowercase b, and this is followed by uppercase C. We do the same with the other ones, right? So we are just replacing E by its productions here. Once that we are done with E, we need to check with S, sorry, we need to check the last one, which is E. And in the variable E, we also have 2 type 2 productions. E produces C, which is higher in the ranking. Again, we need to replace C by its production. In this case, it's easier because C only produces lowercase a. So we just replace C here by lowercase a, and we replace uppercase C here by lowercase a. And we are done with all the variables. We have removed all the type 2 productions from all the variables with the substitution lemma. Finally, we go to the last step, and we need to transform type 1 productions. Okay, so type 1 productions were the one where we had a combination, a terminal followed by a combination of variables and terminals. According to Greibach Normal Form, we should also have variables following a terminal on this production. So we need to replace all the terminals here on this chain by variables. And we check all the production rules that we have. As you can see, the only variable that we have that is not in the first position is lowercase b in every case, right? In every case, we have lowercase b, which is not in the right position. So we need to introduce a new variable in the grammar, which will be y, that produces lowercase b, and we replace lowercase b by y in every spot, right? So in every spot, we just, instead of typing lowercase b, we type y as a new variable on all of these production rules. And this is the last step. Well, as you can see, finally, we have a grammar that is in Greibach Normal Form, right? Because we have a terminal on the first position of the right hand of each production rule. And then this terminal is followed by a combination of variables, right? So this is the proper way of having something in Greibach Normal Form. We can have also an isolated terminal, and that's fine, right? This is also in Greibach Normal Form. So I'm going to stop sharing my screen now. So thank you for joining me today. If you have any question, don't hesitate to ask. I'm planning to upload more videos to the channel explaining or working on this particularly type of exercises. So have a look to the channel, to the basic theory, to the exercises on how to simplify a grammar, to the theory of Greibach Normal Form. And if you have any question, please don't hesitate to write in the comments or send me an email. I will try to reply all your questions. So thank you for joining me today, and I will see you on the next video.